Hello, and welcome to today's session. As always, I'm your host, Kevin Grote, Technical Partner Manager here at VMware. Today, we're going to be talking more about NSX, and software-defined networking, specifically around the ideas of micro-segmentation inside of the server infrastructure. NSX allows us to address the complexity of micro-segmentation in a feasible way, a way that was never possible before. Where we were always dealing with just north and south traffic, now we're able to also deal with east and west traffic inside of the data center, protecting those workloads potentially from each other, and also allowing for application-centric segmentation and security within the data center. Whether we're talking about files, systems that are communicating with each other inside of our data centers, or whether we're talking about integration and use of contractors and other people that might need access into our data centers at any given time. Micro-segmentation makes all of this possible, and it integrates seamlessly with the rest of the virtual infrastructure, all while commoditizing and creating more flexibility so that you can do everything you want with more streamlined resources and without having to commit to specific hardware parameters. So with that, let's take a closer look into micro-segmentation through NSX for the server infrastructure. So when we start talking about NSX and micro-segmentation for our server infrastructure, we have to realize that we're moving away from paradigms that we've lived with in the past. And business leaders want IT to look like what the cloud leaders are doing. After all, this is how we have upgraded and how we've migrated what we've done for years and years. We have those people that are living inside of the cutting edge, and then everyone else tends to kind of want to follow that and emulate a lot of that technology. And so what does this de-evolution of the status quo look like? Does it look like having no IT and just outsourcing everything? Or does it look like moving toward a new IT where we have internal and hybrid cloud? For a long time, people were looking and thinking, well, maybe outsourcing was the way to go. But predominantly, people have kind of moved away from that, and they're looking toward realizing that internal and hybrid is really the move to make. But then there are other decisions. Do we stay with what we've always done and be confined to hardware? Or do we move toward a software-defined data center that allows us more flexibility? VMware's vision obviously is very clearly inside of software-defined data center. We've taken what we've learned, where we started with the compute capacity and moved away from this clearly only hardware operational model to allow for automated operations for the applications, the virtual machines, and the server infrastructure, giving us the ability to do all of the things that we wanted, to create snapshots, store, move, restore, delete machines whenever we needed, and specifically to make sure that we were agnostic of the vendor, that all we had to do was ensure that the machines were compatible and that we could move between different types of machinery. And this is the core of ESX and vSphere. But it still didn't allow us to address these other two paradigms that existed inside of the data center, the networking and the storage. And we'll be focusing on network in this conversation. We took what we did inside of compute and we're expanding it inside of network and storage. And like I said, inside of network, we're clearly talking about NSX. And with NSX, being able to not just have virtual machines, but to have virtualized networks. Virtual networks that are capable of doing the same thing virtual machines can. We can create them programmatically, snapshot, restore, move them, store them efficiently, and to be able to build in automation and orchestration with not just the machinery, but also the networks and the storage. So what does network virtualization look like? Well, inside of compute virtualization, we had the server hypervisor, which was really just any piece of x86 hardware. And then we allowed the virtual machinery and the applications to commoditize and access that hardware. Inside of NSX, we're doing the same thing. All we're doing is we're breaking apart layer 1, which is really just the cabling and the boxes, and we're commoditizing all of the rest so that everything from layer 2 through layer 7 is handled by NSX. So the workloads that are driving those applications now have access to virtualized network resources. And the best part is we're able to virtualize all of this network on top of the server hardware that we already have. So we're not talking about making any additional investments. We're leveraging what's already there and making it more effective. So now that we know the what of NSX, let's talk about the why. So why do we still need to address this? Well, just because we've addressed in the past, inbound and outbound data center security, and we've protected the data center perimeter, it doesn't mean that we've protected all the other facets of the data center. We could have a critical system within the data center that becomes infected, and it will infect other systems within the data center because it's not being monitored or managed by this data center perimeter protection. And we also have threats that might be lying dormant. You could have an attacker that is leveraging reconnaissance for months and then relaying secret and important data back to the attacker, all because this one system was sitting unprotected inside of a data center. So we're seeing, because of these growths in server-to-server traffic and how it's outpaced client-server traffic, that this need for protection inside of the data center is all the more important. After all, we really need to look no further than just all the exploits that we've seen in the news. So like I said, we're seeing that increase in security breaches, we're seeing an increase in server-to-server traffic, yet today's security model just continues to focus on perimeter defense and firewalling. This is where NSX and micro-segmentation is so different. Micro-segmentation does something that is super important. It assumes that everything is a threat. So this is the idea of zero trust. And zero trust is really what the new networking and security paradigms are about. And it takes all of this and it moves it into clear design principles. So we're able to take isolation and segmentation, secure the VMs from each other, and then provide unit level trust. So inside of each virtual machine, provide specific levels of trust for that virtual machine. And then automate control so that we can take those points of access and ensure that machines can scale and protect from one another and the applications that are moving inside of the data center effectively. The problem has been that micro-segmentation was really just kind of operationally infeasible. I mean, if you think about the fact that a typical data center has two firewalls, maybe one outside going into the DMZ and another one from the DMZ into the LAN network, versus it having thousands of workloads. So directing all of that traffic through those firewalls creates a clear choke point because you're never going to be able to manage it effectively. And the data center perimeter model was cost prohibitive because that would mean that we would have to put in additional firewalls into thousands and thousands of locations. This simply just can't be done. Otherwise, we're going to go back to this idea of having a choke point where everything has to go out and back through one clear firewall. So the way we were doing it hasn't always allowed us to remain flexible as we move forward. So now with micro-segmentation and NSX, we have a clear vision where we have a control plane, which is the NSX manager. And again, that's just a virtual machine. And we have the data plane, which exists and allows us to provide switching, routing, firewall, and even load balancing inside of the virtual network. And we can also integrate with our physical workloads and our virtual LANs to allow for the flexibility that we need. So let's first look at what's happening inside of the data plane. So inside of the data plane, this is where we're getting our isolation and segmentation. We're ensuring that we have no communication between unrelated traffic streams. We can provide for firewalling right down to the virtual machine layer. We can provide for load balancing right into the application stack. And we're able to do all this while ensuring that we remain flexible, because everything is happening inside of the hypervisor. So our network is just as scalable as our hypervisor and our compute platforms. The way we're handling the micro-segmentation is by allowing the distributed firewall to reside just outside of the VM. And this is a really important concept, because if we consider the fact that you have a virtual machine here, and maybe inside of this space, we have your operating system and everything else. And right here is the virtual NIC. The distributed firewall resides just outside of that virtual NIC. So what's happening is, if there is an attacker, someone who is up to no good, they're really only going to have purview into that machine. They're not going to be able to see that layer of protection. So even if they're able to take over and exploit an individual machine, the fact that the distributed firewall resides outside of the virtual machine's awareness means that attackers can no longer gain access and maybe disable the protection that the machine is leveraging. The centralized management allows us to build in and bake in security policies, to orchestrate them centrally, and to also ensure that firewall policies are provisioned, moved, and retired as workloads come in and out of the space. The software-defined data center is really what makes this happen. Moving toward a space where we have advanced services communications, where we have firewalls, distributed routing, and clear communications and orchestration between database, application, web, or any other multi-tiered or multi-platformed application stack. This means that we're moving far away from just having no path of communication to having controlled and advanced paths of communication that are not only secured, but they're also highly flexible and highly repeatable. So what starts this journey with microsegmentation? Well, it starts through logical switching, being able to provide layer 2 communication and to create the virtual network in software. This is what NSX is allowing us to do. By providing that network hypervisor and allowing the logical switches to reside above it, so that machines can communicate inside of virtual networks without having to deal with choke points inside of the physical network space. The logical switching is achieved through overlays, and this is where we get into the ideas of VXLAN. You can have virtual machine workloads all with the exact same IP addresses living cooperatively next to each other because of encapsulation and overlay. This means that we can scale our networks significantly greater than we've ever been able to do before. We then take those ideas of the logical switch and extend it out into distributed routing, where we're able to leverage distributed routers so that only communication that we deem appropriate can migrate from one logical switch to another through the logical routing platform. And again, all of this happens inside of the control and management planes for NSX, which are nothing more than having an additional component inside of the hypervisor and having a couple virtual machines up and running. The distributed routing allows the administrator to leverage one clear point of administration so that that logical routing VM can send updates out to the controllers, and that's going to then distribute the routes to each hypervisor so that, again, our workloads and our distributed routing and distributed firewalling is as flexible and scalable as our host access. So we're no longer limited to just what we can do inside of the hardware space. We take it a step further, and we know that we have the layer 2 communication between machines and the virtual network being created in software. We know that we have the ability to ensure that through layer 3, we're only communicating as we deem appropriate. But now we can add more. We can add distributed firewalls. And so now machines that are residing inside of these virtual networks can be firewalled off from other virtual networks, and we can also ensure that we're restricting traffic, specifically to the traffic that should be moving through these distributed routers and through these distributed switches inside of the virtual networks. And what's really cool is, if we think about it, we're able to take all of this, and because all of it resides on top of the network hypervisor, we have the ability to clone, snapshot, to effectively store, to move, and to secure all of these networks the same way we're doing virtual machines. Distributed firewalling is at the core of the concept of microsegmentation. It takes our NSX network, which we know is made up of distributed network elements embedded in each hypervisor, and then it allows each virtual machine to have its own firewall. Again, because that VM and its virtual NIC, because that firewall is residing outside of the awareness of the operating system, any attacker who is going to attempt to compromise a system is not going to have any scope or vision into the security that's protecting that system. So if one system becomes infected, the rest all stay safe and our workloads stay up and running as expected, and we're able to address just the one system that gave us problems. This brings us to this true vision of isolation. And I mentioned before that because of the overlay, we can have exact replicated networks residing side by side. Here we have two virtual machines, both with the exact same IP address, but one lives inside of one virtual network and one lives inside of another. But because of the overlay, and because of the way that we're communicating, and because we've decoupled from the physical space, we can repeat this as many times as we want to, all with the impunity of knowing that everything will stay secured, it'll stay repeatable, and it will stay highly flexible, and we're able to commoditize and leverage the physical network as needed. So this is what we look like if we move from the traditional to the NSX data center. Inside of the traditional data center, again, average data center has a couple of firewalls and thousands of workloads. It may have the perimeter and then the inside firewall. Inside the perimeter firewall, we've got all our DMZ machines, and then inside we've got a VLAN for apps, we've got a VLAN for databases, VLANs for services, management, dev, test, whatever the case may be. And we also have a limited number of VLANs. After all, you're really only going to have effectively 4,094 VLANs left that you can work with, which seems like a lot until you start integrating other types of workloads into your space. But with NSX, we now just have a perimeter firewall, and each individual virtual machine inside of the groups with the security policies that are being applied to them can retain their own distributed firewall access. And it also gives us the ability, because of the overlay, to have over 6 million different networks. So that's a big step up. And this allows us to now have great scale, great flexibility, all while maintaining the same type of security that we needed inside of our space to ensure that just because one machine might be impacted, that everything else inside of our groups stays up and running, and we can only need to address the issue at hand. We also have the ability to leverage policies and security groups. And I really just kind of wanted to touch on this because this allows us to automate security operations so that we can create elements, whether they're static or dynamic. It could be based upon the name of a virtual machine. It could be based upon a user ID or an operating system type. And so then, based upon that group, and we see an example here, we might have, an operating system which is Windows 8, and anything that's tagged for production will apply specific policies to that group so that we get the correct antivirus, we get the correct firewall, and we're able to secure those machines as they're being created, and also to make sure that we're not having to secure more than is actually in place and up and running. We can then automate those security operations using sort of an if and then sort of perspective, where if a virus is found, then quarantine that specific VM. Or if we have sensitive data, then allow and or encrypt that data, or maybe restrict access while it's being investigated. Or if we have a vulnerability found inside of one of our databases, then monitor that virtual machine. And so now we have all of these different points of flexibility and integration that we never had before. So let's talk about a couple of use cases. So use case 1, network segmentation. And this is really the core, and like I said, the killer app inside of NSX, where we're no longer restricted just to having a perimeter and then an internal firewall. We can take the perimeter firewall, leverage that the way we always did for the inbound traffic, and then internally leverage the hardware that we already have and the x86 resources and investments we've already made to ensure that we create groups. Maybe one for HR, maybe one for finance, and another one for services and or management. And that each machine is retaining its own firewall, so that if the machine becomes compromised, we no longer have to worry about it infecting or impacting other resources inside of the data center. This allows us to control traffic between groups, even within a network. So if we wanted to control traffic between the database and the application group, we can do that. If we want to ensure that we can control traffic between DMZ and database for HR, we can do that. And also between groups that might live inside of different networks. So really true flexibility, all happening in flight, protected, scaled, and repeatable through NSX. Another use case would be multi-tenancy. And in another one of the videos, we're going to be looking at integrations with vRealize Automation 7. But effectively, if we consider we could have multiple tenants, what's a tenant? Well, that could be a department, it could be a geography, it could be a workload, it could be a lot of different things. But because of the overlays, we're able to leverage multiple tenants, and we can, again, do the same thing we did before. Provide security between different networks, provide security within the groups, and provide security between the machines, all using NSX. And then we can take the whole thing and we can repeat it. Again, because of the overlays, we can have networks identical to one another living side by side harmoniously. And then we can also add advanced services based upon the network or security group, tag, identification, or machine name. All while ensuring that we have no traffic moving back and forth between the networks because of the isolation and the encapsulation layer. Leveraging all of these advanced services also becomes much easier with NSX because of the depth of our partner ecosystem. Integrations with next-gen firewalls like Palo Alto Networks, integrations with antivirus, with Trend Micro and Symantec and McAfee, and being able to provide for greater flexibility in vulnerability management through integrations with things like Rapid. And so having all of these points of integration, which are continuing to grow every day inside of NSX, means that not only is micro-segmentation for our server and internal workloads now feasible, operationally reasonable for us to execute on, but it also means that it allows us to be super flexible, to move away from those old paradigms and move closer to having real, true software-defined data centers that we can protect, scale, repeat, build upon, and secure in the most reasonable and feasible ways possible. I want to thank you for taking time to join me today. As always, I hope you found value in these sessions. Be sure to subscribe to the channel and also to follow me on social media for more updates and information regarding events, streaming roundtables, and more video content that continues to come out regarding these fantastic products. For more information, be sure to check with your local VMware engineering teams. And as always, have a fantastic day. I look forward to talking to you again soon.